Thank you for watching this training on Clean Heating and Cooling Technologies, Heat Pumps 101. In this module, we'll review why clean heating and cooling, what is a heat pump, the benefits, and the difference between equipment, options, and applications. This chart, published by NYSERDA, shows the energy usage in an average New York home. Notice the almost 75% of the home's energy use is for heating and cooling the air and the hot water of the home. Switching to LED light bulbs and using Energy Star appliances can make a significant difference, but you can see by this chart that increasing the efficiency of your home's heating system is the best way to make a significant impact in your home's energy use, therefore reducing your utility costs and carbon footprint. Many people believe that the air conditioning system has heavy energy usage. It's true that window units and other temporary style units have extremely poor energy efficiency, but in the summer, the average outdoor temperature is 85 degrees, and you may set your air conditioning system to 75 degrees. So the air conditioning system is only reducing the indoor temperature about 10 degrees. The air conditioning season is generally shorter in this part of the country than the heating season. Whereas during heating season, the heating system may be trying to make up 30 to 40 degree difference between indoor and outdoor air temperature. An example of the difference between heating and cooling a home is that for a sample home, a heat load calculation that reflects an 18,000 BTU load for cooling could require 35,000 BTUs to heat the home. Typically, the heating load is roughly double that of the cooling load. So when a heat pump is sized, it's sized for its heating requirement, since they do both heating and cooling in one unit. This chart, also published by NYSERDA, explains that 32% of all emissions from fuel combustion are from residential and commercial heating and cooling systems. New York State's goal is to reduce greenhouse gas emissions 80% by the year 2050. Heat pumps is one way to reach this goal. Cleaner heating and cooling systems like heat pumps can significantly reduce your energy cost, increase your home's comfort, and create a healthy environment for people sensitive to allergens and airborne pollutants. By reducing our reliance on fossil fuels, we can reduce overall greenhouse gas emissions. Now, let's learn about heat pumps and how they can help us reach our environmental goals and reduce a homeowner's utility costs. Most heating systems burn fossil fuels to produce heat. There's heat in the air and ground all around us all the time. Even in the winter, we can capture that heat and transfer it to heat a space. Likewise, in the summer, we can transfer the heat out of a space to keep it cool. This refrigeration cycle is similar to how a refrigerator in your home works. This graphic demonstrates a refrigeration cycle. The compressor generates the heat. As the compressor moves, it pumps refrigerant as a hot gas vapor. That hot gas moves to the air coil. The air coil is your indoor air handler or indoor heat pump unit. As the refrigerant moves through the coil, the heat is transferred from the refrigerant into the air. There's a metering device called an expansion valve that monitors the conversion of the gas vapor into a cool liquid. At this point, the system is going from a high pressure system to a low pressure system. The refrigerant liquid travels on to the evaporator. This is the outdoor unit. As the air moves through the evaporator, we are picking up the heat in the air and converting the refrigerant back into a gas. As the vapor passes back through the compressor, it helps keep the compressor cool. If we were to run this cycle in reverse, this same system can be used to provide air conditioning. This is how a heat pump provides both heating and cooling in one unit. There are several types of heat pumps. Ground source heat pumps, or geothermal systems, use the ground as a heat sink. The temperature underground is a more stable temperature than the air. We can extract heat from the ground in the winter and deposit heat into the ground in the summer. Air source heat pumps use the air as the heat sink. Other common names for air source heat pumps are mini splits or ductless systems, although ducted systems are becoming available. Geothermal systems can provide a home's domestic hot water also. There are also heat pump water heaters available. Due to the energy efficiency of heat pumps, there is significant cost savings compared to heating with oil or propane. Each ductless indoor unit is its own climate zone, so each room can be its own temperature. This allows the most flexible range of temperatures throughout the home. Areas of the home that are rarely used can be controlled independently to further reduce the use of electric. Heat pumps have filtration systems that reduce airborne allergens and pollutants. They are a great alternative to systems that burn fuels like oil or propane to produce heat. Since heat pumps use electric to heat or cool the air beyond what they can extract from the ambient air, they work great in a home that has solar to produce its electric. The elimination of burning fossil fuels reduces your carbon footprint by eliminating greenhouse gas emissions. Cooling systems use a metric called a SEER rating to advertise their energy efficiency. SEER stands for Seasonal Energy Efficiency Ratio. The higher the SEER rating, the more energy efficient the system is. Window units and other temporary cooling systems are generally around 10 to 11 SEER. A standard traditional central air conditioning system ranges between 13 to 16 SEER, although higher SEER models are available. A heat pump ranges from 18 SEER to upwards of 33 SEER in its cooling mode. Anything above 18 SEER is considered high efficiency. Ductless systems have particularly high SEER ratings because there's no heat loss in the ductwork infrastructure throughout the building. Tests like a duct blast test can be performed to calculate the amount of air loss there is in the ductwork of a building. There's work that can be done to remediate areas of significant air loss. Thank you for participating in this training about heat pump technologies. For more information, visit www.alpineaironline.net. You can also visit www.heatsmartny.com/Warwick.